the faster way to divide polynomials, but it only works if you are dividing by a linear factor. And when I say linear, I'm talking about powers or degrees. To be a linear factor means that x has to be to the power of 1. That's what it means to be linear. And linear factors are the only ones that will work in synthetic division. So remember in long division, we had a subtraction inside the division symbol. Well, with synthetic division, we're going to have everything opposite. There's going to be a lot of changes for synthetic division. So I'm going to show you how to set this up. And of course, just like long division, you must account for all missing powers. So let's get started with A. We have x cubed minus 4x squared minus 5. What power of x are we missing?
We're missing x1.
There you go. X to the first power,
Mhm.
which means we account for it by making it 0x. So we have all our powers, 3, 2, 1, 0. I've been doing this all day. I haven't put the file in the chat. Unless you downloaded it already, then perfect. You're ahead of the game. Yeah, do this. There you go. There's the notes in the chat in case you don't have them. Okay. Now, like I said, everything's going to be a little bit backwards for synthetic division. So we're dividing by x minus 3, which is still our divisor. So this is still our divisor. But with our divisor in the form of x minus c, we are only going to divide by the actual 0 or the root of this divisor. So if it's x minus c equal to 0, we're going to use the value of c in our synthetic division process. So this means when I set up, I'm going to have my divisor out here. Since it's x minus 3, I'm going to use a positive 3. And now when I write my division symbol, it's now going to be, you can say, upside down. So here's our division symbol. And then inside is going to go the dividend, just like last time. So here is the dividend. But the biggest change here is that you do not put any variables. You only put the coefficients. So for x cubed, the coefficient is 1. And then -4, 0, -5. Okay, so there's our setup. And for synthetic division, the first number always comes down. There's our setup. Any questions so far? Good there. All right, well then, the next thing we're going to do is we're going to take our divisor and multiply it by the quotient down below. So 3 times 1, of course, is going to give me 3. And like I said, in synthetic division, everything is opposite. So in long division, it was subtraction. In synthetic division, it's going to be addition. So you'll get -4 plus 3, which will give me -1. And we do it again. 3 times -1 will give me -3. And then 0 plus -3 gives me -3. And then 3 times -3 will give me -9. This will give me a remainder of -14. Oops, same color. Okay. So now we have to rewrite the quotient back into a polynomial form. So yes, this part that we end up with is called the quotient. And of course, whatever's left over is still called the remainder. Okay, So listen closely. Synthetic division only works if we're dividing by a linear factor, which means that when you divide, you will reduce all the powers by 1, meaning that if x cubed was the leading term and we reduced it by 1, what would the new leading term be?
Zero.
We're reducing the power of 3 by 1. So what would the new leading power be?
2.
So we'd have x squared minus x minus 3 plus the remainder over the original divisor of x minus 3. There it is, y'all. Now, was that a lot faster than long division?
Yes.
For sure, right? So that's your setup. You only put the coefficients, you put the dividend, the coefficients of the dividend, and then you only put the value of c as your divisor, and then you just have to rewrite whatever your quotient is plus your remainder. Okay, all good?
So will it always be 1 less than the degree you started out with?
That's it.
Okay.
Good question, because we're only dividing by a linear factor of x.
Okay.
So it will always reduce the power by 1. Okay. Cool. Again. All right. B, 2x to the 5th plus 5x to the 4th minus 2x cubed plus 2x squared minus 2x plus 3. Are we missing any powers of x?
No, we are not.
5, right? We have 5, 4, 3, 2, 1, 0. Perfect. We have everything we need. Okay. Which means, what is my divisor going to be?
-3.
-3. Good. And then we set up the symbol and we only put the coefficients of the dividend. So what am I going to write?
2, 5, -2, +2, and 3.
Nope. Forgot the other -2.
Oh, I'm sorry.
You're good. And again, the first number always comes down. And you can even count them off to make sure you have all of them there. This was 5, 4, 3, 2, 1, 0. Just to make sure it matches up with the above. Okay, now let's begin. -3 times 2, -6. And we're adding. You'll get -1. -3 times -1 is +3. -2 plus 3, you get 1. And then -3 times 1, -3. 2 plus -3, you get -1. And then 3 times -1, you get +3, which leaves you with 1. And then -3 times 1 means we get -3, which leaves us with a remainder of 0. Everybody good with that? Okay, well, let's go ahead and rewrite the quotient, which is right there. So there's our quotient. And remember, we have reduced by 1. We reduced all the exponents by 1. So what is my leading term going to be?
2x to the 4th.
Good.
Or
Minus.
minus x cubed.
Plus.
X squared minus x plus 1.
There you go. And since our remainder is 0, we don't have to write 0 over x plus 3 because that's just
0.
0. And there it is. Okay, well, something special about having a remainder of 0. If you ever come across a remainder of 0, this means that our linear factor, or our linear divisor is a factor of the dividend. So if you ever get 0 as a remainder, this means that x plus 3 is a factor. And to go into more depth what that means, if I put x plus 3 and multiplied it by our quotient and simplified, we would be back at the original dividend. Crazy, right? So in a way, synthetic division helps you factor polynomials with more than 4 terms. Well, you can do it with 1, 2 terms, 2 terms or more. But if I told you to factor this, you would probably have no idea where to start. So synthetic division helps us break down polynomials and tells us if we have a factor correct or not. Okay. Any questions on that?
Yes, will there be like any situations where we have to where long division is better suited and a synthetic division is better suited for others, or is it they're both the same thing?
Remember, we only use synthetic division if we're dividing by x minus c.
Okay.
So for long division, let's say we were given this same problem, but we said divide by x squared plus 1. We can't use that in synthetic. We would have to do long division.
Okay.
Now, another fun situation, let's say if it was x squared minus 1. Well, in this case, synthetic division would work because what could you do with x squared plus 1? I mean, did I say plus 1? X squared minus 1. Could you factor that?
Yes, you can. X plus 1, x minus 1.
There you go. X plus 1, x minus 1, which means you now have 2 linear factors that you could use in synthetic division. But that's on if you see you can factor.
Okay.
If you can't break it down into linear factors, then you're going to have to use long division.
Okay.
So long division for exponents 2 or greater, synthetic division for exponents of 1, linear. All right. All right, let's do it. Let's keep moving. All right. C, 4x to the 6 minus 3x to the 4th plus x squared plus 5. What powers of x are we missing?
We're missing cubed. 5, actually, I'm sorry, 5 cubed and 1.
There you go. Zero x plus 5 divided by x minus 1. 6, 5, 4, 3, 2, 1, 0. Perfect. Okay, which means we have all powers accounted for, which means if I have x minus 1, we are going to use 1. And what am I writing for my dividend?
That'll be 4, 0, -3, 0, 1, 0, and 5.
1, 0, 1, 0, 1.
Good old binary.
There you go. All right. And then the 4 comes down and we begin. 4 times 1, is 4. We are adding 0 plus 4 is 4. And then 1 times 4, 4. 1. And then 1. Which gives me 1. And then 1 again, which will give me 2. And then 2, which will give me 2. And then 2, which will give me 7. Yeehaw. Remainder of 7. Did I do that right? 4. Yeah, we're good. Okay. So there it is again. There is the breakdown. There's the quotient. So how do I put this back into polynomial form? What do I write?
4x to the 5th.
4x to the 5th plus
4x to the 4th,
4x to the 4th plus
x cubed,
x cubed plus
x squared,
x squared plus
2,
2x
or 2x.
plus 2. And since we have a remainder, we're going to get 7 over x minus 1. There we go. Woo! Cool. All right. Any questions on that? And since we got a remainder, this means that x minus 1 is not a factor. Okay. Yeehaw. Okay. D, same thing. 2x to the 4th minus x cubed plus 2x minus 1. What power are we missing?
We're missing squared.
Missing squared. So we put a nice little placeholder there. And then divide it by x minus 1/2. Perfect. Set up 1/2. Do my division symbol and only put the coefficients. 2, -1, 0, 2, -1. Make sure everything's accounted for there. And then the first number comes down. And let's do it. 1/2 times 2, you get 1, which will give me 0. 1/2 times 0 gives me 0. 0 plus 0, we get 0. And then 1/2 times 0 again is 0, which that'll give me 2. And then 1/2 times 2 gives me 1, which means we get a remainder of 0. Yeehaw. There's my quotient. And how do I put it back into polynomial form? What do we start with?
Start with 2x cubed,
2x cubed plus what?
2.
That's it. 2x cubed plus 2. And since we have a remainder of 0, this means that x minus 1/2 is a factor. Yeehaw. All right. Any questions on that page? Who's liking synthetic division more than long division?
Definitely I do.
Yes.
Synthetic
great.
division is my favorite subject in all of college algebra. I actually enjoy this shit.
There you go. Carl loves it. Well, he's probably going to love the next sections. That's when it gets crazy.
I like all of it. I like the process of it. I legitimately enjoy synthetic division. It's like the only thing in math that I like that much.
It's a good time, right? Okay, look at that. Last one. 3x to the fourth plus x cubed minus 3x plus 1 times x plus 1/3. Would you like to do this last one, Carl?
Sure.
right.
Okay, let me get see if I can find the link to your
I'll probably have to send it again.
I thought I saved it.
Bum, 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 bum. I
don't
tried to
have
put
saved.
Ryan to work, but his laptop was broken.
Uh,
I was like, oh great. There you go. I sent it to you. Boom.
let us see. Let us see. Yes. Okay. R6 synthetic division. I have to
One
s-
above it. Yeah, 2021. There you go.
There we go.
Hey, that's my writing. Perfect.
All right. Gross. I love it. I love it. Okay. That's too big. Oh no. What am I? Okay. That works. All right. What's chat saying? Okay. All right. So our coefficients are 3, 1, skip a power, 0, -3, and 1. And our factor is -1/3. We get our 3 for free. Do our multiplication. 1/3 times -1/3 times 3 is, do this first one for you for everybody. So we get 0 when we add that, and then that will give us a 0. When we multiply across, we add down 0. -1/3 times 0 is another 0. We bring down a -3. -1/3 times 3 is 1. We get a 2. So when we rewrite this, we have to remember to drop our power by 1 because we did x to the 4th divided by x. That's x cubed. So we will get this 3x to the 4th plus x cubed minus 3x plus 1 is equal to 3x cubed minus 3, right? Because this would be cubed, second, first, 0 power minus 3. And then we have a plus 2 divided by the quantity x plus 1/3. That's it.
Woohoo!
Easy peasy.
There you go, guys. All right. Any questions on that one? I guess not. All right.
Assume that's a no.
All right. Well, that was synthetic division, and we are done. So if you have questions, stick around. If not, enjoy your spring break. Don't forget anything. Nothing's due during spring break. That would be evil.
Oh,
I-
man.
actually,